Two markets can print the same advancing and declining issue counts and still produce completely different volume breadth. One had a single heavily traded listing carry the tape. The other had participation spread across hundreds of names. Issue counts give every listing one vote. This index counts shares, and because it counts shares, it inherits something the issue count versions do not. Double the allocated volume across the whole series, and every increment doubles, so the entire cumulative path doubles with it. That is not a bug in the formula. It is the reason you must name the input unit before you interpret a single magnitude. This lesson has 3 parts in order. First, the formula, what the input unit is, and how the shared tracking engine turns it into an oscillator. Then the seed, 2 initialization states, the exact observation where output becomes legal, and the declared cumulative starting level. Then the code, and the evidence gate that has to run before any of it. The complete article is linked in the video description. On the fintechbuilder.com, it carries the full data contract, edge cases, source code, worked examples, and an interactive playground. Start with what is actually observed. For every resolve session, take up volume and subtract down volume. The result is a signed number of shares, and that unit travels with everything downstream. Compare that to the issue count members of this family, where the input is a count of listings that advanced minus a count that declined. Those give every listing one equal vote regardless of size. This one is weighted by whatever actually traded. So the two answer different questions, and sharing the same engine afterwards does not make them interchangeable. Now the shared tracking engine. 2 exponential states run on the same input. The fast state closes 10% of the distance to the new observation each session. The slow state closes 5%. Subtract slow from fast, and you have the volume oscillator. Those 2 rates carry the conventional labels of 19 and 39 periods, because alpha equals 2 over period plus 1. But read that label carefully. It does not turn exponential memory into a finite window. Old observations decay geometrically toward 0. They never drop out exactly, the way a value leaves a rolling window. The seed is where implementations quietly disagree. This package seeds the fast state with the simple average of observations 1 through 19. It seeds the slow state with the simple average of observations 1 through 39, which means before observation 39, the 2 states do not both exist, so there is no oscillator to publish. The status field says so explicitly, warming fast, then warming slow, then ready. Observation 39 is the first legal output, not an approximation of 1, not a 0 placeholder. The first observation where the comparison the algorithm is making is actually defined. Then the cumulative layer turns an oscillator into an index. Take the declared starting level, which is 0 in this package, and add every ready oscillator in session order. That gives you 3 pieces of live state, not 1. The fast trend, the slow trend, and the running index. And the starting level only translates the path. It shifts the whole line up or down, and it changes nothing about the daily increments. So if you compare 2 systems and the shapes match, but the levels do not, look at the declared seed before you look at the arithmetic. Watch the sequence on a real teaching path, not just the final number. At observation 39, the fast state and the slow state are already apart. So the first ready oscillator is a genuine comparison of 2 memories. At observation 40, the input jumps to 1.2 million shares, and the fast state moves much further than the slow one. By observation 45, the input has flipped negative to minus 800,000, and the gap between the 2 states has nearly closed. Read it in that order. The input changes first, the fast state reacts more, the slow state follows, and the output records their separation. Here is the property that distinguishes this member from every issue count sibling. Take that same observation 45 and double every source volume across the whole series. The input goes from minus 800,000 to minus 1.6 million. The oscillator goes from about minus 23,800 to about minus 47,600. And the index goes from about minus 241,000 to about minus 482,000. Exactly double everywhere. The direction pattern is unchanged. Only the magnitude scales, and it scales linearly with the unit you declared. A number alone is not enough to publish this. Up volume, down volume, and unchanged volume must all be non-negative, and they must reconcile exactly to a positive total volume. The volume unit and the adjustment basis must stay constant across the whole series. And if the venue, the unit, or the basis changes, that starts a new governed series rather than continuing this one. Every record also carries session order, effective time, availability time, revision number, evidence state, and series identity. Those fields are not metadata decoration. They are what makes the number defensible. Before any arithmetic runs, the evidence gate decides whether there is anything to calculate. Resolve one ready revision per session at the requested knowledge cutoff, and ignore any revision that became available after it. Then hold 3 cases apart, because they're genuinely different. A validated zero is a real observation, and it updates both exponential states toward zero. A missing or provisional session performs no update at all, and a broken volume partition is invalid, not neutral. When the gate fails, the result exposes no ordinary points, so a partial path can never look authoritative. Corrections are where the cumulative layer charges you twice. Fix one old session and the fast and slow states after it are all wrong, because the recursion carried that value forward. But this member also accumulates, so every index value after that session is wrong as well. You cannot patch the final number. You replay from a trusted checkpoint before the corrected session, and you rebuild both the exponential suffix and the entire cumulative suffix. And a revision that arrives later can never change a result you already published an earlier cutoff. The reference code separates 3 responsibilities on purpose. 1 resolves evidence at the causal cutoff. 1 transforms a single validated record into this topic's input unit, which here is just up volume minus down volume. 1 updates the unrounded fast, slow, oscillator, and cumulative state. That separation is what makes review possible. A correct subtraction cannot hide a broken source partition, and a correct recurrence cannot hide future information. Python and TypeScript share one fixture and the same reason codes, so the 2 languages cannot drift apart quietly. So where does this sit in the family? 3 input choices: raw issue counts, ratio adjusted issue breadth, and raw allocated volume. 2 output choices: read the current gap or accumulate it. This member is raw volume, accumulated. Choose it when the cumulative history of share-weighted participation is the actual object of analysis. Do not choose it when you want equal votes per listing or when your volume allocation contract is not stable. Sharing the 10% and 5% engine does not make any of these 6 interchangeable. This index is not defined by fast minus slow alone. It is defined by 4 things together: the input unit, which is signed share volume, the 2 initialization states, seated at 19 and 39 observations, the declared cumulative starting level, and the evidence boundary that decides whether anything gets published at all. Keep the recursive state unrounded. Publish nothing before observation 39. Treat 0 as data and absence as withheld, and replay corrections through both state layers. The complete article and interactive playground are linked in the description. Next in this family is new highs minus new lows. Continue the learning path at thefintechbuilder.com. With a full McClellan articles, source code, visuals, and playgrounds, connect this topic to new highs minus new lows.